day all of you. Today's gate question is, consider a rectangular coordinate system with unit vectors ax, ay and az. A plane wave traveling in the region z greater than or is equal to 0 with the electric field vector E bar is equal to 10 cos 2 into 10 power 8t plus beta z ay bar is incident normally on the plane at z is equal to 0, where beta is phase constant. The region z greater than or is equal to 0 is in free space, and the region z less than or is equal to 0 is filled with a lossless medium whose permittivity epsilon is equal to epsilon naught, permeability mu is equal to 4 mu naught, where epsilon naught is equal to 8.85 into 10 power minus 12 farad per meter and mu naught equal to 4 pi into 10 power minus 7 Henry per meter. The value of reflection coefficient is, okay, we'll see the solution. Yes, what is the problem here? A plane wave is traveling in the region z greater than or equal to 0 is with this E bar and is incident normally on the plane at z is equal to 0. Okay, so what is this problem actually? Take the z is equal to 0 plane. Z is equal to 0 plane is nothing but xy plane. It is nothing but xy plane. Imagine an xy plane. Now what is this? This is z greater than or equal to 0 and this is for z less than or is equal to 0 medium. Okay. So let it be medium 1 and let it be medium 2. Medium 2. Okay. Yes. A plane wave is incidenting normally. Yes, let it be incidenting normally. And what is that wave equation? E bar equal to 10 cos 2 into 10 power 8 t plus beta z ay bar. Okay. Yes. The region z greater than or is equal to 0 with the electric field vector is incident normally on the plane at z is equal to 0 where beta is phase constant. Z greater than or equal to 0 is in free space. So medium 1 is free space or air medium. You can call it as air medium. And z less than 0 means the medium 2 is a lossless medium. Lossless medium. With as the medium is 2, the permeability R2 as 4 and epsilon R2 as 1. For medium 1, epsilon R1 is and mu R1 is 1. Okay, I'll explain it clearly. Actually, epsilon means the permittivity of any medium is epsilon naught into epsilon R. Okay, so for medium 1 it is free space. So your epsilon R1 is 1 means for medium 1 epsilon is epsilon naught. Okay, so here epsilon is epsilon naught, and in the same way mu is equal to mu naught mu r. Permeability is also mu naught mu r. And for the free space mu r is 1, so the permeability becomes mu naught. But what happens here? As the medium 2 is lossless medium and epsilon mu r2 and mu r2 is 4. So what about mu now? 4 mu naught. Clear? Same way, what about epsilon? Epsilon is nothing but your epsilon naught. Now your electric field vector is incidenting on the xy plane normally and is moving into the z less than 0. What do you have to find? You have to find the reflection coefficient. Yes, definitely as the second medium is different from the first medium, automatically there exists a reflected wave from the boundary xy plane. Okay, now to calculate the reflection coefficient, we need reflection coefficient R. You have to use the formula eta 2 minus eta 1 by eta 2 plus eta 1. What is eta? Yes, what is eta? Eta is intrinsic impedance. Intrinsic impedance of the medium. Okay. So what is eta 1 here? And the medium 1, eta 1 is, the formula for eta 1 is, actually the intrinsic impedance formula is root mu by epsilon. So for eta 1, so for the medium 1, eta 1 is root, as mu is mu naught, epsilon is epsilon naught, it is 120 pi. If you substitute mu naught 4 pi into 10 power minus 7 divided by 8.85 into 10 power minus 12 farad per meter, you are going to get 120 pi. Okay, it is very important. The intrinsic impedance of the air is 120 pi or 377.7 ohms. Okay, now for medium 2, eta 2 is root, same mu by epsilon, but it is, yes, your mu is 4 mu naught by epsilon naught. Okay, so it is 2 into root mu naught by epsilon naught is nothing but 2 into 120 pi is your eta 2. Therefore, what is the reflection coefficient? Eta 2 minus eta 1 by eta 2 plus eta 1. Okay, what is eta 2? 2 into 120 pi, that is 240 pi minus 120 pi by 240 pi plus 120 pi. So what is the answer here? It is 1 by 3. The answer is 1 by 3. Okay, so the reflection coefficient is 1 by 3. What are the important formulas here? The intrinsic impedance, eta, that is root mu by epsilon, and the reflection coefficient in terms of eta. Okay, that is eta 2 minus eta 1 by eta 2 plus eta 1.